Compound interest. Compound interest is defined as the interest calculated on the initial principal and also on the accumulated interest. In this case, the investor earns interest on the interest. There are three ways of calculating the compound amount and compound interest. You can either do it manually, you can use the compound interest table, or you can use the compound interest formula. To compute manually, you'll be needing the formula I equals PRT. I stands for interest, P stands for principal, R stands for rate, and T stands for time. Let us consider this problem. Johnny Go invested $20,000 at 6% interest compounded annually for 2 years. Manually calculate the compound amount and the compound interest of Ms. Go's investment. In this problem, we have $20,000 for the principal, 6% for the rate, 2 years for the time, and 1 for the period per year since the interest is compounded annually. Since Ms. Go invested annually for 2 years, then we will have to use 1 for the time in the solution using the formula, and use it 2 times to complete the 2-year investment. In this case, we multiply $20,000 by 601 to get $1,200, which is the interest for the first year. We now have to add the principal, which is $20,000, by the computed interest, which is $1,200, to acquire the new principal, which is $21,200. We repeat what we have done using the I equals PRT formula, but now using a different principal. So we multiply the new principal, which is $21,200, by 601 to get the new accumulated interest, which is $1,272. Now that we computed the annual interest for 2 years, we are ready to compute for the compound amount by adding the most recent computed interest and computed principal. $21,200 plus $1,272 equals $22,472. $22,472 is the calculated compound amount. To compute for the compound interest, subtract the initial principal from the compound amount. $22,472 minus $20,000 equals $2,472. The next method involves the compound interest table. You will need several formulas to get the compound amount and compound interest. First is the formula for the interest rate per period, where you will divide the nominal rate by the periods per year. Next is the formula for the compounding periods, wherein you'll multiply the number of years by the number of periods per year. The last formula is for computing the compound amount, wherein you'll multiply the table factor by the principal. Let us use the same problem to see if we will obtain the same answer. First, you have to compute for the interest rate per period by dividing the nominal rate by the number of periods per year. For this problem, we divide 6% by 1 to get the interest rate per period, which is 6% or 6 hundredths. Next, we need to compute for the compounding periods by simply multiplying the number of years by the number of periods per year. 2 times 1 equals 2. We will be needing these two values we obtained to get the table factor. Proceed to look at the compound interest table. Earlier, we computed for the number of compounding periods, which is 2. And we also computed for the interest rate per period, which is 6%. In order to get the table factor, we get the value where these two intersect. We now get 1 and 1,236 10,000s as the table factor. Now that we have the table factor, we can already compute for the compound amount by multiplying the table factor by the initial principal. 1 and 1,236 10,000s times $20,000 equals to $22,472, which is the same compound amount that we calculated manually. To compute for the compound interest, we repeat the same process wherein we subtract the initial principal from the compound amount. $22,472 minus $20,000 equals $2,472. Let us solve another problem. William invests $6,000 at 8% interest compounded quarterly for 7 years. Calculate the new table factor and find the compound amount of William's investment. In this problem, we have $6,000 as the principal, 8% as the rate, 7 years as the number of years, and 4 as the number of periods per year. To calculate the interest rate per period, we divide the nominal rate by the number of periods per year. 8% divided by 4 equals 2% or 200ths. To calculate for the compounding periods, we multiply the number of years by the number of periods per year. 7 times 4 equals 28. We will have a problem since the compound interest table provides a row of table factors for only until 25 compounding periods. To acquire a value for the table factor, find 2 compounding periods that represent half or values as close as possible to half of the compounding periods required. Multiply these 2 table factors and round the new table factor to 5 decimal places. In the problem, we computed for 28 compounding periods. The 2 compounding periods that represent half of the periods required are both 14. The table shows that the table factor for 14 compounding periods at 2% rate is 1 and 31,948 hundred-thousandths. We multiply this table factor by itself to get the new table factor. The new table factor, rounded to 5 decimal places, is 1 and 74,103 hundred-thousandths. The acquired table factor will be used to calculate the compound amount. To compute for the compound amount, simply multiply the table factor by the principal. 1 and 74,103 hundred-thousandths times 6,000 equals $10,446.18. $10,446.18 is the compound amount. To compute for the compound interest, simply subtract the initial principal from the compound amount. $10,446.18 minus $6,000 equals $4,446.18. The last method that this video will tackle is using the compound interest formula. The compound interest formula is A equals B times 1 plus I raised to the nth power. A stands for compound amount. P stands for principal. I stands for interest rate per period, which is calculated by dividing the nominal rate by the number of periods per year. N stands for total compounding periods, which is calculated by multiplying years by the number of periods per year. Let us consider this problem. Angelo invests $2,400 at 8% interest compounded quarterly for 7 years. Calculate the compound interest and the compound amount of Angelo's investment. In this problem, We have $2,400 as the principal, 8% as the nominal rate, 7 years as the number of years, and 4 as the number of periods per year. In this problem, the principal is already given, which is $2,400. We would only need to compute for the interest rate per period and the total number of compounding periods. To compute for the interest rate per period, we need to divide the nominal rate by the number of periods per year. 8% divided by 4 equals 2% or 2/100. To compute for the total number of compounding periods, we need to multiply the number of years by the number of periods per year. 7 times 4 equals 28. Now that we have the values for the principal, the interest rate per period, and the total number of compounding periods, we can now compute for a compound amount. To compute for the compound amount, simply substitute the values for the principal, the interest rate per period, and the total number of compounding periods to the compound interest formula. A equals P times 1 plus I raised to the nth power. $2,400 times 1 plus 0.02 raised to the 28th power. The answer is $4,178.46. To compute for the compound interest, simply subtract the initial principal from the compound amount. $4,178.46 minus $2,400 equals $1,778.46. We accomplished learning how to compute for the compound amount and compound interest manually, using the compound interest table, and using the compound interest formula. I hope you all learned by watching this video. Thank you for watching.